Early. Don't you think we can start 3 minutes early? Huh? Fam? Can we start 3 minutes early? Welcome to the stream. Let's us get going. I'm excited about tonight. Excited to do some really cool stuff. Alright. Welcome everybody to Keenan Can Do live stream on Thursday, March 5th, 2026. Okay, look, so on Journal here, on Journal, I did figure out how to do a dark mode here. So we have dark mode, so if I'm drawing some things on the tablet, we should be able to see it better now. What else do I say? So what I wanted to do today was continue on finishing up the files portion of the learning that we were doing here in Beej's Guide to Programming, and play around with some more Emacs stuff. We might dig into doing some Emacs specific optimizations for some of the stuff, and I can go over a little bit of what I've done with Handmade Hero, and I might go into the blog and just do some blogging, so you'll just kind of be with me watching me do some blogging shortly. What I did want to say though before we begin is I wanted to ask, I'm not going to beg, but I wanted to let you guys know that I have 91 subscribers. So we're making a push for 100. Tell your friends if you like this. Let's get 100 subscribers, and I'll try to make something cool on Raylib, like 100 subscribers flash screen or something. It might use some Gen AI on that a little bit. I do that in my day-to-day work. But in any case, it'll be in C, and it'll be all of our code along with the generation. So yeah, let's push for the 100 subscribers. And that's all I'll have to say about that. So if we go back to Beej's Guide to Programming, we were looking at reading one line at a time. We did that with strings and lines. We have lines and strings. Oh, and then the whales was for the formatted text, if you remember. And then writing text to the files. That's where we're at right now. So actually, I'm going to leave this open right here. And what I like to do is do some practice, kind of mental practice, to make sure that you kind of understand what you did in the previous one. So I'm kind of just going to make a file and call it practice read.c. And what we're going to do is just make sure that without looking at the documentation, if I can do the reading logic for kind of reading in some information from a file. So let's create our file, practice some text, some.text. This is some of the text that I want to read in the file. I would like to use both fgetC and fgets. So I remembered that. I am not sure if I remember enough to use the scanf or the scanf, right? Okay, so there's our file that we want to read in. We'll go back to here. Okay, do we need strings? Can't remember. We'll look at the documentation. We're not going to look at Beej's programming, but we're absolutely okay to look at the programming documentation. So if I want to say fgetC.3, that should be okay. So it needs to, it's just standard input stdio. It's just that. Okay. All right. So having said that, we can create a buffer. So we're gonna need a char. Okay, no, with char gets, it's not a buffer. It's an int buffer because you need enough to need the end of file might not be char. Remember, because the end of file EOF might be larger than a char. Okay. And then we need a file pointer, and we need to open it. So we go fp equals f open dot sum dot text. And we want to assert. That we do need the assert logic, right? Include standard input.h. Assert. We want to assert that fp is not equal to null, right? And then we can just do f close fp, right? I think so. Compile. Those aren't our compile. We want it to be practice read, and it's practice read.c. Practice read.c. Oh, I don't know why I always make these capital sometimes. Are not allowed. Ah, yeah, they're not allowed. They're not allowed. Yeah, forgot here. So with handmade hero, he uses the C++ style. Man, what's going on, Keenan? Shift is what I want, not that. Okay. Open. He uses the C++ style. Okay, so what other error did we have though? Oh, yeah, I need the file. Too few. I need the file name. Aha, so I did make a mistake, so let's go look at fopen in the docs. The mode. Oh yeah. The mode. And we want the mode to be just R for that, right? Okay. I did assert H. Oh, I didn't. Seriously? I said I needed assert H, but then I didn't put it in there, did I? Okay, so asset H, good old asset H. Assert. Unused variable B. Warning control reaches end of void function. Yeah. Okay, cool. Well then, but we can now go to practice C, practice read, and nothing happens. That's to be expected. Now we want to say while the F get C of B is size of B. We want the size of the, we need the length, and then FP is not equal to end of file. Then we want to print F, Control S, the line, which is B. Right? Who thinks that we did okay? Oh no, too many arguments. Expected 1, I have 3. Oh, because I did. Okay, so let's do F gets instead of F char, because that would be the different one. Any errors? Warnings. Are there any errors in here? Errors, so it's just warnings. Enough use the scan. Is it null? Yeah, because it's not going to be... Was there no end of file? What did I do wrong here? Fgets. Let me go back to the documentation and fgets. Read the next character from the stream. Reads in at most one less than the size from stream and stores in the buffer pointer to. Reading stops after an EOF or a new line. If a new line is read, it is stored with the buffer. A terminating null byte is stored after the last character in the buffer. After an end of F or a new line. Okay, what am I doing here? Printf S the buffer. FC set style. C set style. Why is it not? I needed to set style. I need to work on my init file. So maybe after we get done with this chapter, we can mess with some init file stuff. Size of B, is it end of file or is it null? Oh, it is null. But why is it null? Reads in at most one less than the size from stream and stores them into the buffer pointed to by us. Reading stops after an end of file or a new line. If a new line is read, it is stored into the buffer. A terminating null byte is stored after the last character. Unget pushes C back to stream. Cast to... Only one pushback is confirmed. Is the end of file? Man. The following are defined as macros. These names may not be reused without first removing the current definitions with undef. Okay. Get a line from a stream. Fgets, get a line from a string. Reads in at most. If a new line is read, it is stored in the buffer. While it's not equal to end of file. How come it wouldn't have been equal to end of file? So, does that mean that... Yeah, I don't... Why is it... Because end of file would be stored in the buffer, is that why? Reads in at most one size. Characters stream and stores them into the buffer pointed to by S. Pointed to by S, okay. So Reading stops after an end of file or a new line. If a new line is read, it is stored into the buffer. The terminating null byte is stored after the last character in the buffer. Reading stops after an end of file or a new line. If a new line is read, it is stored into the buffer. The terminal null byte is stored after the last character in the buffer. Oh, okay. Reading stops after an end of file. Let's go back to Beach's guide to see if we can get an understanding of what that is about. It returns null on end of file or error. Fgets is even nice enough to null terminates a string when it's done. Let's do BUS. Let's do his library reference. Insert standard input. Where's it at? Okay. Gets fgets. From a console or file. These are functions that receive a new line terminated string from a console or a file. In other normal words, it reads a line of text. The behavior is slightly different, and as such, so is the usage. For instance, here's the usage of gets. Don't use gets. In fact, if C ceases to exist. Okay. Fgets char int size file stream. Gets doesn't, and that's what the size parameter is for. It will read at most size minus characters, and then stick a null terminator on after that. Oh. I was going to add another reason, but that's basically the parameter I'm using to use gets. One difference between the two functions will devour and throw away the new line at the end of the line, while gets restored at the end of a string. Here's an example of using fgets from the console, making it behave more like gets, with the exception of the new line inclusion. In this case, the size of operator gives us the total size of the array of bytes, and since the char is a bytes, conveniently gives us the total size of the array. Okay, so what I could essentially do here, it looks like, is you could say, we could essentially go f close again, but we could above that just call fgets b size of b and then fp, and then we could just print that f because we know it's not 1024 bytes. We know we control the size of it, so I'm just testing to make sure that's kind of my logic thinking is right there. We'll see real quick here after this. Printf, what happens? Why? Compile. No errors. And it's gonna do. Oh, it does them all again. Why is it? But it's only gonna go to a kilobyte, so it's gonna stop in a minute. I think. Well, I'm really trying to understand this. Let's see if I set this to smaller. Instead of set it to like 50. No, not 50, 64. still going? Why is it still looking like it's doing a for loop? So it doesn't look like it just grabs everything, so my estimation was wrong. Here's stream from I could say the amount of bytes I want. Let's say give me 20 bytes, 16 bytes. I don't know why it's doing that. What did they compile? Yeah. Oh, it's been erroring out this whole time. Oh man, I need to start using. Okay, you know what? I need to start using the error thing. Yeah, so I need to start using that and get to the error. Right now. Gee, what? Control X. That. Passing argument 1 of F gets from incompatible pointer type. Because this is supposed to be a char pointer type for that one. That could be what it is, guys. Hey, that's what the reading is for. Gets, yes. It's a frickin' char. But then why is F? Get char is just char. Expected before token, yeah. Okay. Now I'm going to the errors though, that's a good. Control reaches end of void function, return 0. Now, let's see. Okay, that's some of the text. Okay, so I was right. It's reading just the amount of bytes that it comes from there. So why was my... So the wow, it says unless an end of file is there. It'll never see the end of file because the end of file is larger than a char. I think let's it'll never see the end of file, right? Like It will never see the end of file. Come here. Come here. It just said on there that it wasn't the right pointer type. So when I had the integer pointer type, it wasn't kind of working the right way. But the end of file, from what we saw with B just before, it needs to be the integer pointer type. So I'm just... I don't know what to think about that. Let's try. So let's try again. Let's let's just comment this stuff out, and we'll uncomment this out. Okay, and we want to change that to end of file, and I'm guessing it's never going to reach it again. Oh. Comparison between pointer and integer. Yes. So it's never going to reach end of file. So why does the man say that fgets reads in at most one less than size characters from stream and stores them in the buffer pointed by size? Reading stops after an end of file or a new line. If a new line is read, it is stored in the buffer. Oh, okay, so it stops, but I'm not comparing it. I'm not comparing it because I can't compare the integer. It's not the right value to compare. That makes sense. That makes sense. Cool. Cool. I need to start doing some org mode stuff. You know, some good old org mode, some notes.org on here. Right? I don't even know how to use org. I think it's something like that. Like some C programming, some notes from Beach, C programming. Be cool if I could get org mode to do the actual blog, right? And then I could come there and say like fgets won't your fgets, you know, I don't know. You are not going to be able to stop on the end of file because the pointer is an int and the pointer is a char and end of file is often int size, right? I don't know. That's some notes. Let's go back to the thing. Okay. So that's why they do that's why they do no. Right? That's why they do no. That's why they do no. So now we can read it. So, okay. So we did that. Now let's do the char-based one. Again, as we're kind of messing around. So with the char-based one, we'll just comment this out. And let me go back and look at the docs for fget char. Fget char is just the stream. It just takes in the stream. Or end of file on end of file or error. So with that one, because it's a stream, the file stream, with that one, right? So we do have to have this as an int then, don't we? Right? And then we could just say here, while fget c fp is not equal to end of file, right? We could, is it put? Put? I don't remember. Is it put? Let's see. Man, put C, put ch, yeah. Puts the char, yeah. Put C. To a stream. Writes the character C to stream. To stream. What stream? Oh, I don't have the thing, do I? Oh. Huh. That's very interesting. So... I don't want to look at the docs before I try this out, because I want to try this out on my own. And my own. Don't want to look at the docs, so F gets C. I want to look at those docs though. F, that's puts. Do. File stream reads the next character of a stream, returns it as an unsigned char cast. Ah, okay. Look at that. I can just say. We don't need a buffer though, do we? Do we need a buffer here? Let's just leave the buffer. Well, no, I shouldn't leave it because it's going to complain. Let's just leave the buffer and we'll say we have int. Reads the next character, returns as an unsigned char, cast to an int. Oh, it is an int. Oh, yeah, okay, so we'll just call it buff. And okay, and then I say buff equals that, and then it puts C buff. I don't know if that is cast the right way. Let's see, recompile. Oh yeah. Few arguments expected to. What was the other argument? So is it just print then? Print and print. I guess just print F. I thought there was a print for just buff characters though. So let's do printf, and this is going to be a char buff. Okay. And this is just going to print a bunch of characters here. All there. Because a new line is also a character. So I essentially printed everything out by just reading it one character at a time instead of reading it as one. But I wonder if you could. Yeah, I don't know about like how casting to numbers and stuff like that yet, so we'll move on from that. Okay, so good practice. That we did some. So what was my other note that I wanted to note there? That the F gets okay. We're not going to. Yeah, and then a note for F put. F get C. This one returns the char, but it is cast to int so that you are able to have the end of files. Smiley face. Smiley face. Smiley face. Okay. Let's go back to here. Okay, so go back to reading a line at a time. We did that. Formatted output, writing text files. Okay, so now we're doing writing. Much the same way we can use fgetC, fgets, and fscanf to read text streams, we can use fputC, fputs, and fprintf to write text streams. To do so, we have to fopen the file in write mode by passing wchar as the second argument. Opening existing file will instantly truncate that file to 0 bytes for a full overwrite. Whoa, so that's something you have to be careful of. We'll put together a simple program that outputs a file using a variety of output functions. Let us do that. We'll call the output program output.c. And we're going to include, of course, standard input.h. We're going to have a function for that. We're going to return 0 from that function. And we're going to printf hello world. Because why wouldn't we? And we're going to compile it. We'll remove that. And what do we call it? Output to output.c. Good. And then we could test it. Output that. There we go. Hello world. Guess what I forgot? Guess what Keenan forgot? I need to set like a stream thing on there for whenever I forget the the new line, I do something fun. It's like a fun thing. I don't know. I'm just really starting new with the streaming. I'm just kind of beginning. Okay, there's hello world with the new line this time. All right, now we need to go back to the documentation. And we're going to say we need a file pointer, of course. Int x equals 32. What is that for? I don't know. Oh, it's printing to F and file print. Okay. So we have a file pointer, of course, is fopen, and we're going to call it output.text. And of course, it's going to be in writing mode. So once that happens, it will be, and then let's fp to close it. And we're gonna put a char there. So that's fputc. B is the char. FP. Okay, we'll put a new line too, I guess. But I don't need to say that. I know what that is. Okay, and the next one is we're gonna output. Put a char to the file. Okay, so that's fprintf, fp, x equals %d n x. Okay, and then fputs is a non-formatted string, I guess. I don't know why they're different. We're gonna probably learn here in a minute. And then we could print hello world. We don't need to print hello world. Let's unprint hello world. And then let's compile this. Okay, compilation finished. And let's run it. Okay, and then cat output.text should have information in it now. And it does. Very, very cool. I think it's cool. You think it's cool. We both think it's cool. Good water. Buc-ee's. You guys ever been to Buc-ee's? Okay. So what is the delay? There's a bit of the delay. Okay. So now I want to look at those. So fputc. Man, fput. C. Writes the character C cast to an unsigned char to the stream. The stream is a file stream. It's equivalent, except that may be implemented as a macro, which evaluates stream more than once. Okay. Fput is equivalent to put char. Okay. What about fprintf? Man fprintf. When described below, the functions print. Oh. So print, yeah, print, but is it format? So what's the F then? Fprintf. The functions vprintf are equivalent to the functions printf, fprintf, dprintf, printf respectively, except that they are called with a var list instead of a variable number of arguments. These functions do not call the van macro because they invoke the va_arg macro. The value of AP is undefined after the call. See standard arguments 3. What? Okay, like. You know you're starting to learn something cool when, like, come here for a minute. You know you're starting to learn something cool. I mean, everything I read. Like, I'm gonna read it again. I'm not gonna have it on the screen, but they're the same as are equivalent to the functions of printf, fprintf, dprintf, except that they're called with the VA list instead of a variable number of arguments. These functions do not call the va_n macro because they invoke the va_arg macro. The value of AP is undefined after the call. See standard arg3. I think I'll wait to see standard arg3 for quite some time. But if y'all want to go see standard arg3, you please report back to me how fun standard R3 was. Okay, so let us mess around with understanding what that is. All of these write under the control of a format string that specifies the subsequent arguments. So fputs. Oops. That's another thing you should have on the list every time I make duck go up 1,000,000 times. Okay. So, yeah, that produces that file. We got that file. Fun fact, since standard out is a file, you could replace line 8 with fp equals standard out. And the program would have outputted to the console instead of to a file. Try it. Yeah. Cool story, dude. But what about fputs? Because we didn't at all look at that. Man, fputs. Writes a string S to stream without its terminating null byte. Oh. That's why we had the terminating null byte at the end. Okay. Okay. Fun enough. But fprint. But what about... Not fun enough, because... What is the signature? F... constant. So the string... and then the stream. Oh, that doesn't take any format specifiers. Okay. So it just puts the string to... So it's just a random... It just allows you to put a string there. Okay, that makes sense. So that means that the fprintf.3, this one, file stream, and then the formats. Okay, so it's the save as printf, except you put in the stream, which you could put in, I mean, so remember he said, funny fact, you could do that in line 8. I'm guessing because it takes in that we could also just, oh man, we could also just fprintf here, and we could do standard out, and we could say successfully added, right, %d and x. Right now we're saying I am writing it to a file along with fprint. Oh yeah, it's fprintf. Yeah. fprintf. Recompile. That we are able to output it directly there. Yes. So now that part won't be there when I cat it. It's just like I kind of essentially it's used for logging. Like I logged out what I did. So that's really cool. That's really cool. I like that. This is C. Like I've been programming in these higher level languages for a long time. I can show you. I can probably show you the first thing I programmed, unless. Let's take a little hiatus right now. Unless the site's gone or the handle's gone. So there used to be a handle on what was called Twitter X, and we have. It was called Next One News. Yeah, there it is. Yeah, okay, so this is very interesting. So one of the first things I wrote back in 2014, so we're looking at 12 years now, is I wrote a bot using the Python Twitter API that would output how much papers that my team wrote on. I was working for a paper company, and they would go out there and they would write subscriptions to sell the newspaper. And in order to motivate the team, I got them to. I got this little bot go up, so where every time you follow it, and every time someone on the team wrote an order, it would add it to. It would have a running total for the orders for that day. So like if we went down to something like April 9th, like let's go to the beginning of the day. Okay, so we wrote our first order at 11:19, and then at 12:44, 12:54, 13:49, 14:14, 15:14. Wow. That's interesting. Whose followers? Musink 1, Jesse Vincent, and see, yeah, because I wasn't even a yeah. Huh. So that's just a little aside. I just wanted to show you, kind of, and to do that in C would be super complicated. But I just wanted to show you a little aside on. So I've been using higher level languages. That was like a high level Python API that did that. I don't even know where the code is anymore for that. It was just maybe it was a couple 50, 60, maybe 100 lines of code to do that, and it attached to a Google spreadsheet that would identify when the orders were written and then update it to Twitter. So it was all really cool to do, but I never really like kind of understood how the memory works in the machine and low level, and that's really what this series is about. This is what my stream is about, is really kind of just digging deep down into the machine and understanding, almost like, you know, like Casey was saying with Handmade Hero, coming back to like performance and things like that. So for instance, at work, we're working on something right now where we've got Azure Synapse pipeline running that's working with 1 billion rows of data, easily billions of rows of data, and it's a hog. And something tells me, although it might take more effort to build it with a lower level language, with something where you're actually managing the memory, I bet that C would be able to do it, given it enough memory and stuff, and you do it correctly. So, I mean, maybe in the future I will build something that moves in that direction. But I digress. Let's get back to what we were doing here. So now we're in binary file IO. So far we've just been talking text files, but there's that other beast we mentioned early on called binary files or binary streams. So you know what? I want to add another. I want to add. How do you int y, and I want to add. Let's just say what I want to do instead of saying it, right? I want to add a input from standard in. Think we can do it? I think we can do it. So what we would do, we would f. So first let's print f, enter value for y, right? And then I want to say y equals f get c standard in. But there's not, it's not a char. So is there an f get like int? F get C unlocked, FG console, F get WC, F get C, reads the next character, returns an unsigned char cast to an int. Oh! So it would be an int. Okay, well let's see if that really is what it does. Okay, and then I want to print that to the file handle, saying y equals %dn, y equals %dn y, and then I want to duplicate that and say that we successfully added y. Recompile. What do you think? First try? First try. Alright, so let's see what that actually does. Enter a value for y. I'm going to say 42. Successfully added 32. Successfully added 52. Because I put a char in there. And I typed 4. So let's do it again. If I just type 4, yeah, so that's what it is. So we need to get input from the, whoops. What? I don't want settings. Why is settings even up right now? Sorry, chat. Hold on a minute. Okay. So I want to get f fgets does int size fgets reads in at most one less than the size of stream and stores them in a buffer pointed to. Reading stops after. If a new line is read, it is stored in the buffer. A terminating null byte is stored after the last character in the buffer. So it would be 3. So bytes. So that means we could do fgets. We could say 3. We need a buffer now. Int buff 3. Okay. And then buff. Is that it? No. Incompatible pointer type. Oh, because it's supposed to be char. Is that? Oh, okay. I just had them mixed up. Integer from pointer without cast. Oh. What? We might need to do a little bit more work with that. Let's go back to documentation. Let's see. So I could do a single char one. I think we're gonna have to put in notes that once we get more knowledge, we can do the other. So yeah, so if I do output. Oh. Standard in. if I do 1, or if I do A, it's going to add 97. If I do large A, it's going to add 65. So yeah, we're going to have to figure out later at a later time how we actually get the values in there. Okay, let's continue on. Now we're in binary. So far we've been talking text files, but there's that other beast we mentioned early on called binary files or binary streams. These work very similar to text files, except the I/O subsystem doesn't perform any translations on the data like it might with a text file. With binary files, you get a raw stream of bytes, and that's all. The big difference in opening the file is that you have to add a B to the mode. That is, to read a binary file, you open it in RB. To write a file, you open it in WB. Because it's streams of bytes, and streams of bytes can contain null characters, and the null character is the end of string marker in C. It's rare that people use the fprintf and friends functions to operate on binary files. Instead, the most common functions are fread and fwrite. The functions read and write a specified number of bytes to the stream. To demo, we'll write a couple programs. One will write a sequence of byte values to disk all at once, and the second will read a byte at a time and print them out. Okay, it's about an hour. I've been streaming for about an hour. Sorry, tired. I'm gonna set the timer for just a small. I'm just gonna get a small break to get something to drink, maybe to eat. Small break, and we'll set the timer to 5 minutes. I need to work on the timer code a little bit as well. Okay. So that's the timer code. So we'll do a small break and then we'll be back. I'll be back in 5 minutes and we can continue on. All right. What if I came back early? Would that be allowed? Am I allowed to come back early? Would you like to see me come back from my break a little bit earlier than the 5 minutes that I originally said? Alright. Alright. I am not. What's his name? Alright. Matthew McConaughey. I am not Matthew McConaughey. I am Keenan Nananhanahe. Okay. So let's do one of these binary files. So we've just been talking about files. So binary, and it says it's this, and it says it's that. So let's go back open to output. And that's binary. So let's do binary.c. Of course. You know what I'm not going to do this time? I'm not going to forget to, well, first off, return 0. Second off, I'm not going to forget to hello world. Put the new line character in there. What I might forget though, oops, I don't want to recompile. I want to compile something new. And this is binary.c. First try. Binary.c. Hello world. Okay. Alright, so what's his determination? We're going to need, of course, a file pointer because that's everything. Probably should end the line. And then we have some bytes. Unsigned char bytes 6. And these are the bytes we're going to put there. We're going to put byte 5, byte 37, byte 0, byte 88, byte 255, byte 12. And then we're going to open a file called probably binary. Oh, we could just do output.bin because it's bytes. Output.bin. Because it's bytes. That's what bin means. Writing for binary. Arguments are, in the call to write, the arguments are a pointer to the data to write, size of each piece of data, count of each piece of data, and the file. Right. Bytes. Size of char 6 FP. And of course we gotta close it, don't we? F close. FP. Alright. Let's compile that. Oops. Error. Expected 4. Expected 4, but I only saw 2. Is it? Because this... Pretty sure I put 4 there. So when you put size of in a function, does that turn it into a... That's weird to me. Size of char. That's it? That's all it was? Really? So why is that? There's the bytes. There's the bytes. File output that bin. Data. It's data. Data. So have to look that up because that doesn't make any sense to me. Size of operator, right, yeah. The return type is size T, yeah, okay. Float, size F. Oh, and then you could, okay. You can also specify a raw type, but you have to wrap it into parentheses. Oh, that's interesting though. That's interesting though. Interesting note. Size of. You can use as operator as size of some type, but for built-ins, must wrap in parens. Don't know why, but it's obviously the truth of the matter, because that's what just happened to us just now. So, okay. Those two middle arguments are pretty odd. Basically, what they want to tell the function is we have items that are this big, and we want to write that many of them. This makes it convenient if you have a record of a fixed length and you have a bunch of them in an array. You can just tell the size of one record and how many is right. In the example above, we tell each record is the size of a char, and we have 6 of them. Running the program gives us a file output, but opening it in a text editor doesn't show anything. Friendly, it's binary data, not text, and random binary data is just made up at that. If I run it through a hex dump program, we can see the output is bytes. Oh, do I have a hex dump program? Because I am Linux, apropos hex dump. Yes, hex dump. Hex dump what? What is the commands? Hex dump. Let's see. There is the files. That's what we see. 05250058 FF 0C, because 255 is FF, yeah. Many Unix systems ship a program called hexdump. The blank is the offset within the file that this line of output starts on, which is 0. The 0525 are the byte values, and this would be longer if there were more bytes in the file, and on the right between the pipe. Symbols is hexdump's best attempt to print out the characters that correspond to those bytes. It prints a period if the character is unprintable. In this case, since we're just printing random binary data, that's part of the output, it's just garbage. But if we printed an ASCII string to the file, we'd see that in there. So if I went back to here, and let's say the first two I want to set to 95 and 65. It might be 96 and 65. I don't know, but we're gonna find out right now. Hey, okay, so it's 96. Must be. Okay, cool. So then X is 88 then. Interesting. And those values in the hex do match up to the values in decimal that we wrote out. But now let's try to read them back in with a different program. This one will open the file for binary reading. We'll read the bytes one at a time, and FRead has this neat feature where it returns the number of bytes read or 0 on end of file, so we can loop until we see that printing numbers as we go. In running it, we see the original numbers. Okay, so one more file tonight. Let's do it. Okay, so this would be input. Binary input. can't spell. I cannot spell. Look, that one error gave us all that stuff. Very cool. Woohoo! Okay, so let's look at fread now. Man, fread. Binary stream. Oh, okay, so you can get the stream size. Okay. As we saw in the struct section, the compiler is free to add padding to a struct as it sees fit. And different compilers might do this differently, and the same compiler and different architectures could do it differently, and the same compiler and the same architectures could do it differently. So pretty much they can just do whatever they want. They just do what they want, when they want, however they want to do it. They're doing what they want. They're just want doers. Doers of want. Okay. What I'm getting at is this. It's not portable to just write fwrite, to just fwrite an entire struct out to a file. Oh, okay. When you don't know where the padding will end up. How do we fix this? Hold that thought. We'll look at some ways to do this after looking at another related problem. Numbers! Turns out all architectures don't represent numbers in memory the same way. Let's look at a simple fwrite of a 2-byte number. We'll write it in hex so each byte is clear. The most significant byte will have the value 12, and the least significant will have the value 34. Unsigned short v equals 2-byte number. Yeah, so each byte is clear. The most significant byte will have the value of... Why is that a byte? Oh, because the byte's 8 bits, 255. Yeah, okay. Value. What ends up in the stream? Well, it seems like it should be followed by write, but if I run this on my machine, the hex up the result I get, the reversed, what gives? Little Indian. Little Indian! Little Indian. You know what? I wish that I had on here just another side real quick. I like my Emacs bindings. Where's extensions? Do they have a Emacs bindings? Edit with Emacs. Emacs key bindings. Emacs key bindings. I want the most users. Or recently updated. Emacs navigation for Firefox. Okay. That would be cool. Let's see how it works. Obviously it's not going to work on the add-ins, but let's see if it works here. Huh, no. Oh, it just gave me a new. Add-ons, Emacs. Manage extension. Emacs, yeah. Currently only supported for Mac. What? What is that? So, yeah. Fail. This was a fail. Okay, you know what? I think that is a good point. So this is about Indianness. We talked about that. Some write the most significant, and some. This means if you write a multi-byte out straight from memory, you can't do it in a portable way. Similar problems as a floating point. So how can we fix all these problems? The summary is to serialize, which is a general term that means to take all the data and write it out in a format that you control that is well known and programmable to work. As you might imagine, this is a solved problem. There are a bunch of serialization libraries you can take advantage of, such as Google's protocol buffers out there and ready to use. They will take care of all the gritty details for you and even will allow data from your C program to interoperate with other languages to support the same serialization methods. Do yourself and everyone a favor, serialize your binary data when you write it to a stream. This will keep things nice and portable even if you transfer data files from one architecture to another. Well, I don't know what protocol buffers. Protocol buffers. Okay. We'll look that up later. Protocol buffers. Okay, well, I think for tonight, that is going to be it for us today. I hope that everyone enjoyed the stream. I certainly enjoyed streaming with you. And I would like to wish you all a good evening. I would like to tell you that I appreciate you being here and joining me on this journey, and I hope to see you guys later. We'll talk to you later. Bye.